learned about different kinds of chemical and physical changes. Before we go over the activities you performed, let's review the difference between a chemical reaction and a physical change. Physical change is defined as a change in the form of a substance without changing the chemical composition of the material. A good example is mixing sugar and water. This demonstrates a physical change because sugar and water mix, but do not combine chemically. If the water is evaporated from the mixture, the sugar will remain behind. A chemical reaction is a process that changes one or more substances into one or more different substances. This differs from a physical change because the composition of the material actually changes. There are some key things that our senses can't detect that point if a chemical reaction has taken place. Some include a sound, a color change, an odor, bubbles, or a temperature change. A good example of a chemical reaction is digesting food. Our bodies use different things to convert food into building blocks, such as sugars and proteins, that it can use to grow. In the first week of Chemical Transformers, the activity involved pennies, vinegar, and salt. Dirty pennies were put into salt and vinegar was added. The pennies became clean. This is an example of a chemical change because the composition of the penny is changing. The dirty penny has an outside layer called copper oxide that has a greenish-gray color. This layer forms because oxygen in the air reacts with the copper in the penny to form copper oxide. This is also a chemical reaction. Then the vinegar and salt react to form hydrogen chloride, which is a powerful acid. This acid then reacts with the copper oxide on the outside of the penny to remove it, and the result is a shiny new-looking penny. Where can we see this kind of chemical change on a large scale? The Statue of Liberty is made of copper and it has become green over time due to copper oxide. In order to clean the statue, workers used the same type of reaction you did with the pennies. During the second week of Chemical Transformers, the activity involved an interesting fluid called oobleck. Oobleck is made using cornstarch and water and is an example of physical change. The water and cornstarch never change composition. They just mix together to form a suspension of cornstarch and water. This is what gives the fluid its interesting properties, especially when a force is applied. When a quick force is applied to oobleck, it almost reacts like a solid. When a force is left on oobleck, it begins to behave like a liquid. This video demonstrates oobleck in action.
You should try. All right, it's time for a hoedown.
A hoedown? What's a hoedown?
Hoedown's a dance.
The next week of Chemical Transformers, you made ice cream. This was done by using milk, vanilla, sugar, ice, and salt. The milk provided the base of the ice cream, while the vanilla and sugar provided flavor. The mixture of ice and salt causes the ice to melt at a temperature lower than normal. As the ice melts, it rapidly draws heat away from the milk, turning it into ice cream. The process that you use to make your ice cream actually isn't that much different from how a professional ice cream factory makes ice cream, as you'll see in the following video.
It all begins with fresh cream. The factory stores it in refrigerated silos set just a few degrees above freezing. The silos feed a high-speed mixer that blends the cream with other ingredients. The main dry ingredients are powdered skim milk and plant-based stabilizers and emulsifiers. Stabilizers prevent the ice cream from crystallizing, and emulsifiers allow the mix to bond with air during the whipping process. The other ingredients are sugar and corn syrup.
In the next week, you learned about yeast. Yeast is a living organism that is used in the process of bread making. Yeast eats sugars, and once it digests these sugars, releases carbon dioxide as a byproduct. In your experiment, you combined yeast with 4 different liquids: water, orange juice, apple juice, and Coke. Once the yeast was combined with each liquid, you observed the amount of carbon dioxide gas that was released by attaching a balloon to the top of each container. The more sugar that was present in each liquid, the more gas the yeast would release. In the next week, you were able to observe an oozing pumpkin. This is made by combining a normal pumpkin with yeast, hydrogen peroxide, and dish soap. You used yeast in your last week's experiment, but this one utilizes it in an entirely different way. When hydrogen peroxide, dish soap, and yeast are combined, the hydrogen peroxide is broken down into water and oxygen gas. The oxygen gas wants to escape from the solution, but becomes trapped within the dish soap. As a result, a foam is formed. This is what you observed oozing out of the pumpkin. In the following video, you'll observe the same experiment that you performed, but on a larger scale.
And we'll just kind of see if we get a little reaction.
Okay.
Ready? 3, 2,
All right.
1. There it is.
And-
And here we go. Let's see if you get any reaction here at all. There should be. Oh, that is just beautiful.
In the 6th week of your project, you made carbon dioxide balloons. These were made by mixing baking soda, vinegar, and a water bottle with a balloon on top. First, the baking soda was placed in the top portion of the balloon with the vinegar filled in the bottom portion of the bottle. Once the balloon was held upright and the baking soda fell into the vinegar, a chemical reaction occurred. Evidence of this chemical reaction can be seen in the release of a new product, which would be the gas carbon dioxide, as well as the formation of bubbles. Over the past few weeks, you've been able to observe a number of different physical and chemical reactions. Keep in mind what you've learned as you begin today's activity.